Uh, okay, thank you guys for waiting for a couple of minutes. I'm Nanditi, and I'm glad to welcome you to Symphonies and Syntax, the confluence of chord and classical music. Um, I'm very excited to share this creative exploration of mine with you guys today, which looks at chord as an inherently suitable medium for music making and music learning. It also unlocks some valuable compositional techniques that sit at this intersection, which have proved in my experience as a catalyst and enabler for music learners, as well as it unlocks some new ways of creation for practicing musicians, which is very playful and is full of surprises. I think the live coders here will already understand where I'm going with this. At the outset, I must say that this is not a new topic of exploration, as many of you might know. The idea of the early explorations of algorithmically trying to compose music date all the way back to 500 BC, when Pythagoras started drawing comparisons between music and mathematics, even though the term algorithm didn't exist at that time. And then later on in the 1700s or so, there was this musical dice game. It's a well-cited example of algorithmic music from that time, which is believed to be devised by Mozart, and where you basically had two six-sided dice, and then you had this predefined rule set, which you can use to make combinations of smaller musical excerpts. So it was very procedural and algorithmic in a way. And we are talking about a time where there were no computers yet. Then there's also, from the Baroque era, which is even earlier, Bach was considered to be, his music was considered to be very algorithmic. The compositions were very procedural. There were things like puzzle canons and fugues that are big examples of contrapuntal compositions, which we will come to eventually. But he has this way of putting symbols in the notations for the performer to check real time and then compute internally the patterns that they're supposed to play by looking at the notations. So if you notice there at the end, there is a symbol which is also in the beginning in this graphic, and which basically means that once you've played this, you have to now play it again in reverse. And you have to play it all together. So that's how like contrapuntal composition would happen in this case. We will come to like a practical demo of this as well, but just to give a brief introduction of where we are getting at. And then I think we had this conversation when George was presenting also. In the recent times as well, there have been a lot of research papers and projects that look at composing algorithmic classical music and just generating like loads of it automatically. And in fact, the explorations of algorithmic music have been going on since 1950s, like actually with computers, it's been going on since 1950s. But recently, the challenges that were faced earlier where, human intervention was required to figure out the styles and get the music in a certain style of classical music, let's say. Those are now being addressed because of machine learning and classification, data classification. So now you can even get those styles, like somebody was saying, Carnatic music, right? Like there are so many styles within that as well. So you can actually have that data and classify and get it in the right style. And another reference to Markov chains had happened. So this particular paper on the South Indian classical music is using Markov chains for ragas and the patterns and everything. So yeah, like raga is not just a scale, it's a melodic framework, so that's what they're getting at. But okay, these are all like generating music automatically. My motivation for this talk and the creative exploration is from an artist's perspective. And one thing that is more important for most artists than output is the process of creation itself. So how can we create this scenario where there is human and computer composing together? So keeping both human and computer as the center of the creative process, how can we unlock some interesting ways of creation? So like co-compose essentially, And it's not like the traditional way of music making, and it's not like completely automatically generated, but it's like a computational artist sort of a situation where we are at. And then how this idea moves into the real world, and what are some things that can come out of this exploration. Of course, being able to take styles and techniques and procedures from both Indian and Western classical musical styles, take them and integrate into hybrid music making processes in the modern context. Algorithms can help us with that if we are co-composing with the computer. It obviously adds a lot of playfulness because there is a lot of randomness that we can work with when there's a computer, because you can compute so many things, so many patterns at very high speeds. So like the concept of improvisations is very easy with co-composing. And then, of course, since we are coding, live coding is an interesting format to explore as a performance format, which anyway is happening, and this leads us to live coding as the format for performance. And another useful use case is exploring code and music together as an interesting gateway into music and code both. It could be an alternative pedagogy for music education. From a few experiences that I've had conducting beginner workshops for people who have not been into music or not been into code either, it has turned out to be easy and less daunting for people, even when it comes to music theory, when they're doing it with code, even though they're non-coders, because there is an immediate output as compared to like trying to pick up an instrumental skill, and that's going to take you like weeks, or like vocalizing, that's going to take you a long time. This gives you an immediate output. So learning music theory becomes very less daunting in that way. Not that you shouldn't learn the other skills, it's just that it's a good gateway. So yeah, these are some of the real world explorations and use cases that we can get into if we start to think about code and music together. And before I get into it, I thought I'll just give you guys some background from my personal musical journey, so that I can contextualize and introduce the platform or the tool that I'm going to demo on, which is called SonicPy. So in my early years, I received training in Indian classical music in the Hindustani Khyal tradition of Kirana Gharana, and also like some guitar training where I explored popular genres as well on the side. But of course, life happens, and then I moved into a long corporate stint, and then eventually, without realizing, I figured that my practice has taken a backseat almost for like a decade or so. And then came back, life-altering switch, came back to the very different world of non-profits and music and culture and folk music. So I had joined this organization who has been working on Rajasthan folk music for like 15 years, and they were building a new museum. That gave me an opportunity to do some ethnomusicology research on Rajasthan folk music, and some community programming, events programming, and grassroots work, and of course museum building. So that kind of connected me back to music, and I was like, okay, I should try to get back into the practice that I seem to have forgotten, but needed to find a new way to get into it, easily, because we are out of practice for 10 years. So that's when I started looking for new ways, and I discovered Algoriv. Shout out to Algorivers. So discovered Algoriv, I think in 2018 or something, and figured the wonders of live coding. And I was not a coder at all, but I found it very intriguing, and I was like, I need to try it, and I started dabbling in it immediately and started getting outputs. And I also realized that everything that I'd learned in the classical training, I was intuitively able to translate that into code, even though I didn't know code as such, but it was easy to translate it into coding concepts, because essentially classical music is very procedure-based. And now I continue this exploration through a creative technology studio that I run, which is called Ajaib Ghar, that I co-run with Computational Mama, who's also here. Yeah, and so that's not just about creative coding, although creative coding is a big part of it. So it's everything related, everything artistic that we can do with coding, plus other aspects of creative coding. And then there is this workshop format that we devised, which is for beginners, for in music or art or code, where we bring all of this together in the context of making city soundscapes, which seems to be a very accessible sort of concept, and then see how we can, bring like beginner-friendly ways of introducing these gateways of coding music and coding visual art. So yeah, this kind of made me believe that yes, coding is in fact an accessible medium for music making and performance, from my own experience as a non-coder as well as all the other beginners who've been in the workshops. Yeah, cool. So what made me, who's a non-coder, get into creative coding and coding music is the platform and the tool called Sonic Pi, which I guess some of you will know. But if not, I'll like introduce it and demo it fully for you guys. This is basically an open source programming environment to compose and perform music. It was originally made as an educational resource for schools to teach students coding concepts through creating new sounds. So in a way, it is built for music and built to learn coding concepts. It's built over the Ruby programming language, so it's quite intuitive and easy to understand. And it has a lot of unique commands and functions that are made for music, both in terms of music theory and sound engineering. So we'll see how that works out when I demo it. And yeah, so now it has evolved into this very like a full solution for professional musicians as well as a live coding instrument. A lot of new things are adding all the time. Since it's open source, people are contributing, new things are happening, new features are happening, source code is available. So I've left the link also here if you guys want to ever check it out. So yeah, I think we can do a demo, I guess, but let me know if the sound is fine in the stream. Okay, so okay, so just to demo, this is the most basic, the most simple thing that you can do is just like play a note. This is how it starts. It immediately starts to give you output, and this is just playing a MIDI note, and there are different ways to write the same thing. You can play the note as regular Western notations that we know as well, and then it has this whole way of like playing chords and scales and play them however you want to play them. You can randomize them and a lot of other things. So these are all the functions that are built over Ruby on Sonic Pi. So that's how it's very interesting for musicians. You can just directly play a chord like that. Then you can also create arpeggios, because again it gives you more functions to do that. And you can even play scales fully. So this is showing some potential in terms of composing very easily. Now, if you can just take a chord and like start to make melodies out of it. So this is just going to keep running in a loop and keep choosing random notes from one chord and start to give you some results. If you keep playing around with it, it's going to give you newer melodies. So just the previous one was like a 3-note melody. This is an 8-note because I just changed it to 8 times. So the loop is going to run 8 times. And then you can change the number of octaves. It's going to add more stuff, more notes into it. You can like make it faster. And coming to effects, studio effects. there are like all these studio effects that you can actually work with very easily. There are a lot of parameters also. You can also work with cutoff and frequencies similarly. Yeah. So this is just a short demo of, how it's bringing sound engineering aspects slowly and like musical theory aspects very easily in a very easily understandable code block. I don't think I even need to explain this. It seems to be pretty understandable just by reading it. Yeah, and then, we can do the same with scales. So like people were mentioning, right? Somebody said that, yeah, there are Indian classical scales on Sonipa and other tools. So yeah, this is one of them. This is Bhairav scale, and it's just randomizing. So right now, this one's not randomizing. This is just playing the scale as it is. And then we can start to improvise within that. So now this is improvising within the scale of Bhairav in 1 octave. We can increase that. 2. And then we can create more melodies. Just by putting a new seed, you're going to get some other melody, some other pattern will be picked. Change the seed, change the octave. And you can see it gives us a lot of synths to play around with also. So you can form your melodies, you can play in any synth, and you can add any effects to it. So yeah, that's another way to. Oh yeah, and then of course you have your beats. We'll also get to making beats from scratch. This is just one of the samples that we have. So we've already kind of started composing in like Rag Bhairav, just by using the power of code to randomize and find new patterns out of a set that we have given. Yeah, so that was the initial demo. And it's going to come back. So, sorry. Okay, so yeah, so how code is inherently suitable for composing and music writing? I think we've already seen it. But basically the idea is that classical music is a good way to start coding, coding music, because it's based on rules and procedures. So it's like a guide, essentially. You already have a guide that classical music, both Indian and Western, they provide you, which you can just translate into code, and there you have it. You're already composing something if you're not yet able to compose things out of thin air. So it's a good guide to go with. Yeah, so I don't think I need to stress on this more, but just if you look at the basic meanings of an algorithm or a raga or a canon, for example, from the Western styles, they are all talking about the same thing. Like algorithm is a finite sequence of rigorous instructions to get you an output or to do a computation. Raga is a melodic framework for improvisation in Indian classical music. So basically it is a procedure-based thing. And canon is a contrapuntal compositional technique that imitates a melody and layers it together. So that's, again, another process. In a way, this music is algorithmic. So if you do make classical music with code, you're doing an algorithmic composition. Whether you actually do it on code or you actually just do it traditionally also, it is still an algorithmic composition, because that's how it was devised. So what we'll do is we'll just look at a few concepts and a few techniques that are used both in Indian and Western music, and then try to replicate them in code. So the first one, of course, people are aware that in Indian classical music there is alap and taan, which are both improvised melodies within a set of rules. Alap is, of course, slower and without rhythm, and taans are on a faster rhythm, which is called a drut lay, and they are all improvised on the go within a framework of a raga. So let's do the comparison. So this is Rag Bhairavi, and as I said, it is a framework of melodies. So there are all these rules here that, okay, these are the notes that are to be used. these are some of the Vadi and Samvadi, means like these are few important notes that you must stress on, that you must use, and then a few combinations, patterns that should be a part of the raga to get the right mood that is essential. And like there are some things like a pakad, which is like very definitive of the raga. Like if you play this particular melody, you will immediately know that this is the raga. So it's not necessary just the scale going up and down. It is a combination of notes which is very essential to evoking the right raga. So that is the original Rag Bhairavi, as mentioned traditionally. And then on the right side, these are some bots that I've made in SonicPy that create alaps and tans based on these rules, which is not just telling that these are the notes that you have to use. It is also, there is some level of human intervention here where the notes that are put here in the ring are decided based on which notes we want to stress more on as well. And then what is the time interval between each note, we can also define. So for alaps, we'll have longer intervals. And of course, we are choosing out of everything. Like we are choosing what is the time between each note. And like every time it will be a random one, but they'll be longer because this is the alap bot. And then, of course, the melody, the notes are being chosen from the selection. And then there are some randomizations on how long the notes are sustaining also. They're not always sustaining the same value. Even that is being chosen from a range. So it's trying to imitate how actually alap is done in Indian classical music. And then same goes for tanbot, which will then work on a beat. It'll be a little faster. I think we can demo this. Yeah, that's what the deck says. So there we go. I will just play the scale once, and then we'll the random. So that's just the scale playing Bhairavi, and then we can just do the alap part. Yeah, so this one is just gonna keep going from a seed of like 20 to 200 because alaps can go on for very long. So you can just decide how long you want it to go on for. And 1 second, yes. This is the tan board. Yeah, so this can go on forever. Like, it can go however fast you want. So tanbot can just go on forever, keep changing it's essentially exactly what classical musicians do. Okay, so we're running a little short on time, so I'm gonna do this a little faster. So the next thing is tal, which is a cyclical measure with a fixed number of beats and allocation of beats. I think we've kind of already covered it in George's presentation. Again, a comparison between the traditional way of writing it and then the same thing in code. So the first one is a rupak tal, which has 7 beats in a measure. The second one is a teen tal, which is 16 beats in a measure. And you can see like it's created in a loop anyway. So, Indian classical music runs into a cycle when it talks about tal. Similarly, a loop is also running in a cycle. So it's essentially the same thing. And just gonna do this demo quickly. This is the rupak tal. I think you can hear it. Yeah, and So these are just, all these are just defined here, the bowls. These are called the bowls of tala, right? Like dha, din, din, da. So these are just defined here, how the sound is coming out correctly using certain samples. So like combining a few samples to get the right bowl and then using that in this loop and then using an array to place it correctly where which bowl should come. That's what this is doing. Yeah, and then the final thing, I mean, not final, but for this demo, of course, it is. We have Canons, which started in the Baroque era of Western classical music. Like I said, it's an imitation-based contrapuntal compositional technique where you have a main melody and then you use an imitation of that melody and then you play it together with the main melody. You could play it after a few beats or you could play it together. There are different ways to do it. So there are many types of canons. And Bach was very popular for making this kind of music. So a simple canon, which is just an imitation of the main melody after like a certain duration. And then you have a crab canon, which it plays backwards and forwards at the same time. So it's like mirroring it like in this way where it's showing. So it's playing both ways at the same time. Then you have a very funny thing, which is canon on a Mobius strip, where you have to kind of reflect the staff first. So all the notes become some other notes, and then you play it together with the main melody, like a canon, after a little duration. And then there is a retrograde inversion, which goes even further, where it does both of these reflections, like the crab canon reflection and the Mobius reflection. Like it basically flips it vertically and horizontally on the staff, and then it plays it together. So yeah, these are all the puzzle canons that Bach was like known for. And what we're going to do is just demo this. So I'm not going to apologize for this meme. I think you all will appreciate it. Okay, so I'm just going to play. This is the Pakad of Rag Bhairavi, which is the main melody that I'm using. Okay, so a simple canon. So now the melody is starting to change just by doing these simple procedures. No, not simple, but yeah, I mean, in code it's simple. So this is playing it in reverse together. And finally, the Mobius. So this melody you can actually draw on a Mobius strip and put it together. It's gonna fit perfectly on a Mobius strip because it's a reflection of it, and then you have played it together. And then finally the retrograde inversion, which is the flip both vertically, horizontally, and then play it together. Essentially, it's just one melody, but we have like 4 or 5 ways of, playing around with it, and it totally changes it. Ideally, it should be in 2 different voices as per the actual way of a canon. But I have just used the same voice just to see how we can find new melodies. Just by one single melody, you can create so many. So these are the kind of techniques that lie at this intersection of classical music and code. And even more interesting, when you put Indian and Western classical music together, that is something that I've been exploring. So these canons are now canons in Rag Bhairavi, which I don't think people have thought about it, or maybe they would have, but it's a very unique thing. It's like, now you're multilingual in music. So, and then the next thing that I'm kind of trying to do is do some fugues. Fugues are much longer and more complicated, but I'm trying to do fugues on rags. So like a fugue in Rag Meghmalar or any, any kind of rag from Indian traditions. Just leaving a few links for you guys in the QR codes if you want to look at a full rendition of Rag Yaman in Teen Tal, all done in a live coding performance. And then there is some snippets of a workshop that I conducted on crafty melodies, where we use the same concepts, which is a bit longer, on using algorithms and puzzle canons. I think, yeah, that's about it from me. And if you'll have any questions, I'll try to answer, else I'll DM you on Instagram. Thank you.